So we have what's called the standard form of a linear equation. And the standard form of a linear equation looks like this. AX plus BY equals C. So you get to have an X term, and by the way, A, B, and C represent real numbers. And they can't all be 0, 1, 2 can be 0, but I guess we should say A and B can't both be 0. Then you just have a number. Okay, so those are the rules. So you get an X term, you get a B term, and you get a constant, and that's all you get. Just the 3 terms in a linear equation. Okay, so now we're going to look at this example 2. It says, use the graph of y equals 3x minus 1. Okay, so they give us this graph here. There's a picture of it. It's a line, and that's the equation y equals 3x minus 1. Now, y equals 3x minus 1. Now, in the future, that's what we want to be able to do, is graph one of those lines. But right now we're just getting started. So what they want us to do, for each ordered pair, decide A is the ordered pair solution to the equation, and B is the point on the line. So we have 2 points. We'll start with point A, and it's point 0, negative 1. And they want to know, is it a solution? Well, if it's a solution, what that means is, if you put a 0 in for x and you put a negative 1 in for y, it has to make a true statement. So here's my equation, y equals 3x minus 1, and I'm going to put in a negative 1 for the y, and I'm going to put in a 0 for x, okay? Now, that's an equation, it's a statement. When I simplify it, I'm going to have negative 1 equals 3 times 0 is 0. Sometimes people make a mistake on that. Okay, so I get negative 1 equals negative 1. So yes, that is true. Negative 1 does equal negative 1. So yes, it's a solution. And then part B says, is the point on the line? Well, let's find the point. 0, so don't go right or left, negative 1. So that point right there is 0, negative 1. So, yep, yes, it's on the line. Okay, now we're going to do the other point, B, which is 2, 5. So I'm going to, for the first part, A, I'm going to take my equation again, y equals 3x minus 1. I'm going to put a, and I tell students, if you want, you can write x and y up here just so you remember. So y is 5, and x is 2. So now I have to do some simplifying here. 5 equals 6 minus 1. 5 equals 5. That is a true statement. So yeah, it's a solution. They both work. Yes, it's a solution. It's a solution to the equation. So what we have here, like in previous equations, when we just had one variable, you'd plug it in and see if it was true, and if it was, then it was a solution. But now we have an x and a y. So you have to plug them both in and see if you get a true statement. If you do, then it's a solution. Okay, and then part B, we want to know if it's on the line. So we have the point 2, 5. So count right 2 and up 5, and that's that point right there. So that's the point 2, 5. So yeah, that looks like it's on the line. So yes, it's on the line. Okay. Now, how many points are on that line? Well, there's an infinite number of points. Okay, so you can't list all the points. We can't list all the combinations that make solutions to that equation. There's an infinite number. Okay, so you could put in 10 and for x and 29 for y, and that would be true. And where would that point be? Well, it'd be 10 way over and way up, but it would lie on that line. Notice that the line has the arrows. Okay, so you've got those arrows going in the direction, in the 2 directions. It says it continues on and on. Okay, we'll talk more about this as we graph them.